time for another hopefully short video. Last time I had the fuselage in here, it's now at the airport. That was quite the adventure. It was too big to fit in the truck and actually out of my garage, but got all that taken care of, no damage. It's tucked in behind my airplane in the hangar. So I have my sawhorses. I'm going to take you on a tour here pretty quick, show you how I got them stuck to the floor, have my first couple of spars up on here, learn some lessons, and then do a little more cleanup. So I'll show you what I did. Okay, so here's the up close version. Here's my sawhorses. Again, this is a I-beam that's exactly 46 inches long per the manual. At least the 46 inches part is. It's sitting super level to the floor. I had to shim up this end. Those are tongue depressors that I use for mixing up my high saw. The dead blow hammer is to just barely tap this thing around. You see, yesterday I made some tiny black dots on the floor with a Sharpie pen so I could get it in the right neighborhood. So now I'm just going to mix up some Bondo. It should be real easy to pile it around these tongue depressors. They're just holding it up in the vertical component. Once I get it tacked in place, I can sneak some underneath those feet over there and verify that it's still square to the world while this stuff kicks off, and then I can come back and add quite a bit more once I know it's not going to move. And with one sawhorse in place, then it's off to sawhorse number 2. These are my sawhorses that I referred to a couple times previously. This is just, I found the plans for these online somewhere on some Instructable. Used a bunch of straight studs, made the I-beam part. I actually used Gorilla Glue and some screws to hold everything together. The legs are a little more crude, but they're in solid, so they're ugly, but they work. This one I already have labeled for, say, idiot proof, but I'm pretty creative. So root end, and on the other end is the tip end. These are 30 inches apart, and they will be where the spars rest on top of the block, and then they will index against this face. Assuming I start on the left wing first, then I use this 1/2 inch block here as a spacer to stagger the aft spar. And on this end, use another 1/2 inch block to put in the washout. The fun part yesterday was using my digital tape measure to get everything in line. They want you to have, for memory here, 156 inches from this face right here to inboard face on this side. And then they give you a couple measurements to go diagonal from this corner to its friend over there. Anyway, it's all, I checked it again this morning. Everything is sitting perfectly flat with the digital level, and also my 156 inch dimension and my diagonal dimensions are all either perfect or within 32nd of an inch, so pretty happy with how that came out. These clamps are just as wheel chocks to keep these from rolling, because that would be ugly. And I started to make a video earlier today showing these blocks right here, because I determined there's 3 different views in the Series 5 manual. At least one view shows them on this side, and then I think 2 views show them on the far side. And I thought it didn't matter, but it definitely does, so I had to peel them off and put them in here. One of the reasons I thought it didn't matter whether these were here or here is because in the book it shows the spars extending on beyond the sawhorse, and it doesn't do that, so on this side would not work. What we have here is my wing jig, which I've already highlighted if I did this correctly. It's got 2 spars to set in place. These are clamped. They're just barely snug, just keep things from rolling around. Looks like the orientation that I have them, I'm going to have to open the garage door so that I can insert the internal extrusions. You can see that yesterday I spent some time etching and alodining all of this stuff. Wing spars are a little bit splotchier than I normally get from doing detailed parts, because I was unable to go directly from etch, rinse, and then alodine. Inserts came out. They look real nice, but of course nobody's ever going to see them again. So anyway, mission accomplished. These spars on film, they may actually just look silver, but I can assure you they looked almost white with the at the completion of the etch stage. So they did pick up some color. I am confident they're alodine. You don't always get uniform color in alodine anyway. That's not what it's for. Anyway, as the day goes on, I'll be getting those inserts and hopefully slid into place, and moving on to the next step. All right, another day in the wing factory. Yesterday I got the inserts slid into the spars, appropriate dimension from 70 inches from the wing root end is this little black mark right here, goes to about 130 inches. This gives you 32 inches from the tip end. 2 of them were a challenge, 2 of them went right in. All problems solved, nothing got stuck, galled up, didn't drop anything on the ground, that's a bonus. And did that to all 4 tubes. This crate I'm now going to repurpose to put the flaperons in and store them safely and flat until such a day as I need them. Set up with my 1/2-inch spacer block, but not my washout block per the manual instructions. I used my 4-foot scale, rubbed it lightly on top, and made this line, which is a good way to establish center lines on top. Then the manual has you use a dimension of 19/32 of an inch, plus or minus 1/32. I rounded that down to within the 1/32 tolerance to 9/16, and I'll get into why that is in just a second. First of all, it gives you a slightly increased edge margin from that fairly narrow cap that's underneath here, because it's a little tricky to get the web of that insert vertical, because that's really what everything's clamped in place for. Then they have you lay out a 2-inch staggered pattern. So on my 9/16 line, it goes down, and this is the first day I've had these wing strut attached fittings out. The fittings for the forward spars are identical. The fittings for the rear spars are opposite hand. They have this tab on them, which is supposed to be oriented towards the trailing edge of the wing. It is used to hold the wings when the wings are folded. So don't get that backwards. Not super critical today anyway. All you're really doing is laying these out so that you can trace around them with a Sharpie pen. And the next procedure that I'm going to do is to drill up that 2-inch staggered pattern and rivet. And so what you're doing with these fittings today is just creating a stay out zone, because you don't want to put rivets that are going to be underneath these fittings. So the bonus reason for choosing the 9/16 dimension is the next thing I have you do is roll these fittings over on the forward spars. They tilt towards the rear. They have this witness hole that they want right on that line. And so with my 9/16 line, I'm already good to go. And so I just needed to get the dimension from the center of the strut attached fitting to the inboard edge of spars. And well, it's not super important, the precision of this, other than just the stay out zone. It is kind of nice to read ahead in the manual and make sure you fully understand the nature of everything. So in a perfect world, I could be drilling these up today from this location, but the world ain't perfect, and neither is my airplane. So these, I'm just going to do it by the book. These are going to get traced, popped off, back in the storage tub. Instructions have you drill 4 of these holes and calico and rivet, and then flip the spars over, do the other 4, and then they have you work your way out in some order. I'm going to have to dig in the manual before I drill any holes, so that by the end of today, I'm hoping to have all of the insert rivets, excluding the ones underneath here, in place. So I should probably shut up and get back to work. So this layout here, fittings are on, they've been traced around. These were the holes, ignore the ones on the center line. Kind of messy, the other side's cleaner, I'll show those again, make it easier to follow. But so this rivet's going in, that one, that one, that one. This one's not, because it's underneath the edge. That one's not, that one's not. This one is, even though it's close, so I'm going to double check that before I drill anything, obviously. This one's not. And then it picks up again here. On this side, I laid them out, a little less clutter. Starting on here, go 2 inches from this end and stagger. There I am. I just didn't even draw them underneath here because I had already traced this around here, but you can see that one again gets real close, also close, and so on. All right, so this is the trick that I'm going to use for establishing that. You can use the 19/32 if you really want to, but it's pretty hard to measure that accurately. So 9/16 is my minus 1/32. just laid out several pieces of tape folded under the ears so they're easy to peel off. I struck a center line and then made some marks out here that are exactly 9/16 so I can just make them. These will come out real parallel. And it's one of those things that's not really going to matter a whole lot in the end, but you wonder when you're looking at the manual whether they mean 19/32 in a straight distance like you'd measure with a pair of calipers, or 19/32 of an arc distance like along the surface, and the dimension is pretty darn clear. And so here they are. Here's my line, and I can just peel off one of these, take it over, set it so that the center line is right on the center of my tube, and stick it down, and I'll have 9/16 each side of center line. And the cool part about this trick too is if I just pull them out randomly as I go along, if I find out I'm running short, all I have to do is come back with pieces of tape, lay them in here, and then I didn't even have to measure anything again. I just put my straight edge back on, strike the 3 marks, and I've got another set that's ready to go. All right, before I move on or do any drilling of any holes, in the instructions it does have you, once you get 4 of the holes in here, flip them over and set up the same pattern from the other side. Well, it just occurred to me that the best way to make sure that I find this line on the underside is to use my 4-foot scale and rub the line right now, because they'll be on the exact opposite side of the tube, and that'll be better than flipping them over and trying to find the center of that vertical web inside the extrusion. It's just a trick I figured out that's going to help find the exact opposite side of this tube before I even move anything. Now I've gone through the instructions again carefully, and what it tells you is that you're going to be doing 4 holes per spar. You're going to be doing 2 on the top, closest to the middle, then you flip it over and do 2 on the bottom, also closest to the middle, obviously outside my stay out zone, and then you're using your clamp trick like they suggest for being able to get the spars, the inserts into the spars, to make sure that the extrusion doesn't walk while you're trying to drill it and move. Once you get 4 of them in, 2 top and 2 bottom, then you can work your way out, cleco and drill. The purpose of the clamping is also not to keep things in place, but it's also to minimize the amount of burr that would build up between the 2 surfaces while you're drilling. Makes sense because you can't pull them out to deburr and put them back in as much as I'd like to do that. So time to get out the drill, but I'm gonna get the book out again and read some more. It's probably lunchtime anyway, so then I'll come back and make chips.